Welcome everybody, I'm Ákos from Magazin. Today it's in English because we have a special guest here. It is Eben Upton. He is the founder of Raspberry Pi, in case you don't know.
Distressingly monolingual founder of Raspberry Pi.
Okay. It's all right. Thank you for being here and for the opportunity. And
well, thank you for having me. I mean, this is incredible.
Yeah. How was your impression?
Oh, it's amazing. This is my first Maker Faire since Corona. I think it's actually my first Maker Faire since about 2017 because we had children.
Okay.
We had a little baby, and then Corona came along. So yeah, I've not been to a Maker Faire in a long time, and this is just incredible. Right?
Yeah. Have you been here before?
I've not been to this one before. I've been to the American. I've been to the World Maker Faire in New York, and to the Bay Area Maker Faire in San Mateo. I used to go there pretty religiously to both of those every year. No, I've never. And then I've been to one or two in Britain, but I've never been to one in Germany before.
Okay, yeah. Maybe now you have a new spot.
That's it. This is my new home.
Yeah. And as we all know, you're helping makers around the globe with the Raspberry Pis. Do you see yourself as a maker?
Yeah, absolutely. I mean, this is the culture that we've come from. I mean, I think it's a culture that was maybe a little bit less developed in the UK when we started doing Raspberry Pi. So we weren't really, I guess, we were makers, but we probably weren't exposed to the idea of making as a culture. It was probably more developed in the US, maybe more developed here in Germany. Yeah. But as we kind of grew Raspberry Pi outside the UK, we kind of came into contact with the maker community, with the maker culture, and we kind of found that is, you know, we kind of found our home, I guess.
Yeah. When you're, say you're a maker, in your free time, are you working on project also?
Well, I should be, but I'm not. I mean, one of the tragedies for me personally of Raspberry Pi is that it consumes all of my time. That and my family consume all of my time. So I spend comparatively little time these days playing. Yeah. I think I make one of the best toys in the world with Raspberry Pi, and I have comparatively, it's a little bit tragic that I have comparatively little time to actually experiment with it.
Okay.
It's work-life balance, but you know, I mean, give me 5 years and maybe we'll might be in a little bit of a better place.
So I think a lot of our readers are interested in the Raspberry Pi 5.
Ah, yes.
Is there something in the plans?
Well, obviously there will be a Raspberry Pi 5 at some point. The weird thing about Raspberry Pi 4, of course, is it is 4 years old now. So we launched it in June of 2019. But because we've had a pandemic and a supply chain crisis in between, it simultaneously feels like quite an old product, but also a product that's really only just now starting to find its legs. Obviously, we do need to do something next. Our engineering team has spent a lot of time over the last couple of years on redesigning core products in order to keep them manufacturable in the context of the supply chain crisis. So I think people have been maybe a little bit distracted from thinking about what we do next. But now that now that crisis has abated, what's great, of course, we've got multiple people here selling Raspberry Pis in unlimited quantities at the rated price. You know, it's a real sign that we've emerged from the crisis. Now that's happened, I think the engineering team has a little bit more time to think about what, you know, a Raspberry Pi 5 or a Raspberry Pi Pico 2 or something might look like.
Of course, it's with every product that we're excited for the next.
Yeah.
I mean, the Raspberry 4 is fast enough for 4K streaming, for example. Yeah. There are many people doing media centers with it.
And of course, it did get a midlife. It did get a midlife upgrade. So we launched at 1.5 gigahertz. Yeah. We now, modern Raspberry Pi 4s run at 1.8 gigahertz. So you've kind of got that. You've already got, I guess, what probably in a previous generation we might have branded as a plus product. We might have branded it as a 4 plus. Yeah. Instead, what we did was we introduced it as a running change. We introduced the power supply changes that enable 1.8 gigahertz operation. We introduced those as a running change in the Raspberry Pi 4 family.
Yeah. When you developed the Raspberry Pi, when I remember right, it was meant to animate more pupils to go into electronics, into information technology, and it was like a home computer, a small computer.
Yeah.
The story that came afterwards was a bit different because a lot of makers, more older people, took the Raspberry Pi, and then you deliver the Pico. And the Pico is a microcontroller.
Yeah.
What led to the decision to put it or to develop a microcontroller?
Well, it's interesting. I had a chance to speak about this earlier earlier today at the show, and I think we were using, as individuals, as individual engineers, we've all been using microcontrollers for 10, 20, 30 years. And so we kind of, and then obviously within Raspberry Pi, while Raspberry Pi itself, the core product doesn't have a microcontroller element to it, almost every accessory we produce has some sort of microcontroller in there controlling the behavior of the accessory. So, you know, we have a lot of experience with microcontrollers. You know, we think probably by 2017 maybe, we had a pretty good idea of what we liked about other people's microcontrollers and what we didn't like about other people's microcontrollers. So there's kind of there's always a natural tendency if you're using millions of something a year to think, well, I wonder if we could do this better. And really that's what RP 2040 is. It's the kind of sum of all of the team's experience with the good and the bad aspects of other platforms. It's worked out really well for us. It particularly worked out well for us, of course, because it came along in January of 2021, just as the supply chain for the core product really tightened up. Having access to a piece of silicon that we had almost unlimited supplies of was really helpful, you know, to the extent that we had to divert some of the production of the core product to industrial consumers. Having another product line which wasn't in shortage, which we could use to stay engaged with the maker community, was really valuable to us, and I think to the community as well.
And so when you think back to the home computers, they run on BASIC, for example, the C64.
Yeah, and I saw there's the C64 at the booth next to Berry Base where we are.
Yeah.
It's nice to see it sat there going, you know, ready.
But you took the approach with Python, with MicroPython, because it is a co-product to the Raspberry, or?
I think we believe in Python as the successor to BASIC. It's a natural successor. It has that immediacy, where print hello world is literally just print hello world. There's no scaffolding that you have to, you know, if you look at hello world in Java, it's about 10 lines long, and there's a lot of scaffolding. You have to create a class and a static method and things. So there's a lot of, and when you're trying to teach that to somebody, you have to say, oh, don't worry about this, oh, don't worry about that. And that's a really bad way to open. That's a really bad kind of angle to open with if you're trying to teach somebody about computers. Oh, that bit's hard, that bit's hard, that bit's hard. Instead, you have print hello world. But then, with Python, the bottom rung, like with BASIC, the bottom rung of the ladder is very close to the ground, but unlike with BASIC, the top rung of the ladder is in the clouds. You know, you can write, you know, enormous pieces of professional software in Python as well. So that's always been our view of Python. And then the development probably over the last 5 years of MicroPython by Damien George has really allowed us to bring all those values down into the microcontroller space.
Yeah, cool.
It's great, you know, no more, I mean, you know, absolutely, program your RP 2040 in C. It's one of our supported options, programming in C, C++, assembly language. But if you just want to do something in an embedded environment, 90% of the applications people want to do today, as long as you've got enough memory and enough CPU performance, you can write them in Python and get much higher productivity.
And you have a good entry point, and then when you develop, then you can develop.
And MicroPython supports inline ARM assembler. It supports inline PIO assembler, so you can actually drive the PIO, which is the most interesting aspect of the RP2 architecture. You can actually drive that without dropping down into C.
And there's one thing you have on the market. You have the Arduinos, you have the Raspberry Pico, you have the ESP32, and there are some collaborations. Usually when you think about companies, they are in competition all the time. How is the atmosphere between the companies?
Certainly Arduino are very good friends. Arduino, I guess, probably were 5 years ahead of us. Arduino have walked down this road of enabling educational customers, enabling makers, helping makers transition into professional roles. They probably were 5 years ahead of us down that road. The interesting thing about Arduino and Raspberry Pi, even now we have the Pico, is there's very seldom actually any overlap, significant overlap, between things that are best done on a Raspberry Pi and things that are best done on an Arduino. And that means that we've been able to stay friends, we've been able to be friends with Arduino, we've been able to stay friends with Arduino. Of course, they produce the RP 2040 Nano Connect. They produce an Arduino product which is built on our silicon. And they were one of our early access silicon partners. They had access to our silicon 3 months before we launched, it into the wild. So, you know, they're good friends. Massimo's a great friend, Fabio's a great friend. You know, we know those guys, and I hope we can do more products together.
Okay, cool. It is, the next one is more an ethical question, because with the possibility to to order electronic parts directly from China. There are a lot of makers who have the ability to play with them, build things, and but also a lot of makers don't want to support unethical working conditions. How is your perspective on this?
I mean, I can certainly understand that. I'm not sure. I mean, obviously, we're now a reasonable sized company. You know, we have a whole heap of activity going on around supply chain, around ethics in our supply chain. You know, we work very hard. You know, while we don't build our products in China, we do source a lot of our components for our products in China, and so we make efforts to go and establish that. And we have some fantastic Chinese partners largely in electromechanical, so in PCB and connectors, great. And accessories, some great partners, and we do our best to make sure that all of those people are behaving in a way that we'd be proud of. So as that test, you know, would you be happy to have the situation described on the front page of a newspaper? You know, imagine you know, no secrets. You know, imagine there were no secrets. Would you still be comfortable? And that's always the threshold we've applied to supply chain ethics. I can understand it though, and of course it is. You know, if you are buying through AliExpress, it's extremely hard to be confident that the thing you're buying has been built in a way that you would be proud of.
But do you maybe plan producing more in Europe?
So we produce all of our finished products in Europe, in the UK, and that obviously takes away a lot of opportunity for problems. You know, Sony actually build them for us. So it's not just being built in the UK, but it's being built for us by an international blue chip electronics company. So that really helps. Yeah, when we do stuff with them, when we're building a lot of units, as we are at the moment, when we're in a kind of a surge mode, we actually outsource some of that production, but we outsource it within the Sony organization. So some of the production then occurs at peak capacity, some of the production occurs in Japan, but again, that's the Sony managed factory. Yeah, we can lean on their integrity and their ability to ensure ethics upstream of them in the supply chain. Would we manufacture? I think PCBs are prodigiously hard it would be very hard to bootstrap PCB manufacturing at scale in the UK. It certainly is something that has a lot of scale economy, scale advantage, and our suppliers, Olympic, a company called Olympic in China, are absolutely enormous, and they're a fantastic and very ethical company. Yeah, could you bootstrap connectors? You know, could you make USB connectors in the UK? Well, maybe, and we have looked at that. But really, again, I think you're probably better off finding a Far Eastern partner who you can audit and get comfortable with. You know, not because they have low labour costs, not because they have any particular advantage, other than they just do it all the time and they've been doing it for years and they've kind of squeezed the inefficiencies out of the manufacturing process.
Yeah, and you have to trust them.
You have to trust them. Well, I mean, trust and verify. So trust and audit.
And there is also a discussion at the moment about open source companies going closed source. There are some critics on Prusa that they say their MK4 is open source, but you cannot access every details. How is your perspective on this approach to not open source everything? Yeah,
well, so we've never open sourced everything. We are not an open, you know, the core Raspberry Pi product has never been an open hardware product. There's no aspiration to make it an open hardware product. I think we've been very clear that the goal there is build good hardware. We're not ideological. We just want to build the best hardware for our customers. We want to build a sustainable business that can afford to make the really very large investments that we have to make. You know, I think I said the RP2040 microcontroller, that was a $5 million program, right? You know, if you're going to do programs on that scale, you have to be sure that you can get a return. You have to be sure that you have a sustainable business. You have to be sure you can get a return on the investments you've made. And that doesn't necessarily mean that the right thing to do is to run around making our hardware designs open. I think we try and do as much of our software in the open as we can. And over time, what we've done, I think probably in 2012, very substantial amounts of the software support on the design were in this thing that people sometimes negatively call the blob, start.elf. A closed source component that ran most of the multimedia on the system. I think what we pledged we'd do then, and I think there was some skepticism, but I think we have delivered on it over the decade since, is we've progressively taken components, hardware components, and moved them from being driven by the blob to being driven by open code running on the ARM. And the first of those, of course, was the 3D, the 3D hardware, but now the scan-out hardware and elements of the video codec hardware are in the open. I think we're going to get to a point really very soon where there's no real closed source code. Maybe a little code that does clocks and power, because that code is it's very fragile and delicate, and we probably just want to bake that code in and not have anyone breathe on it. But yeah, outside of that, which is fairly trivial, I suspect we end up with a platform which is closed hardware, but 100% open software.
And sometimes this is a decision to protect the project.
Yeah, we're pragmatic, not, we're pragmatic, not ideological. I think, what's always important is that you're honest about it. If you go around saying my project, and I don't think the Prusa have done this actually, I think people are a little bit down on them unnecessarily. If you go around saying my project is open source and your project is not open source, then you deserve to receive some opprobrium. If you're honest about what you've done and why you've done it, then people can disagree with you. If they disagree with you, they don't buy your product.
Yeah.
But yeah, they don't really have any grounds to complain.
Yeah. When you think about the maker community and how it has evolved in the last years, do you have any wishes for the makers, or are there things that you would like to see in the future?
I mean, I think what I would like to see, and in fact looking down here, what I do see is, I guess, a far greater, the people in this room, particularly the young people in this room, reflect the underlying demographics of society rather better than the adult engineering community does. There are more girls here, in particular. I mean, it's the big one. That it isn't, I'm sure you have these problems in Germany, we certainly have these problems in the UK, that if you look at the people who work in the technology industry, they all look like me, in every respect. And why do they look like me? It's because people like me were the people messing around with computers in the 1980s. Yes. So the demographic problems of today are the descendants of other demographic problems in the 1980s. I think when you look at the demographics of the people down on the floor here, you see that actually probably in 20, 30 years' time, it's very likely that our engineering industry will look a lot more like society, will look a lot less, nothing wrong with people who look like me. But it would be nice if our engineering community looked like society. I think the thing to remember is it is a constant push. It's backsliding is very easy. We need to constantly maintain that pressure to ensure that nobody feels excluded from this. Lots of positive things you can do. Say in our club network, we put a lot of effort into making sure there are female mentors available. And we put a lot of effort into making sure that there are clubs available in schools in less economically advantaged background, in less economically advantaged areas. One of the things we're proudest of with our Code Club network of clubs, very nearly 50% of participants, that's for 9 to 13-year-olds, very close to 50% of participants are girls. Okay. And if you are a disadvantaged school, the way we measure a good way to measure disadvantage in the UK is what proportion of the children of the school receive subsidised food. Receive subsidised school food. Yeah. If on that metric you look at a disadvantaged school and a more advantaged school, the disadvantaged school is more likely to have a club than the more advantaged school. And I think that's, these are all great trends, and I think those are, it's not just a UK thing, it's being replicated in a lot of places. And I think probably when you look down here, what you're seeing is kind of the first output of a lot of those distributed efforts to make the community a bit more representative.
And when you think about the Raspberry Pico, do you think this product is meeting the goal that you set originally for the Raspberry?
It is, and the weird thing about it is, in some ways, it's actually a little bit more like, the programming experience is maybe a little bit more like what I envisaged in the first place. I'd envisaged a very stripped back programming experience, and that's that kind of command line experience you get when you connect a serial terminal. You connect a serial terminal is, I was just writing we have a nice little demo running on Berry-Base's stand where you can experiment with NeoPixels and Raspberry Pi Pico. And I was able to build something with a Pico W, which would go and retrieve the information about what astronauts are in space, who's in space. Okay. There are 10 people today in space. Yeah. There are 7 people on the ISS, and there are 3 people on the Chinese in the Chinese program on the Chinese station. And I was able to light up my NeoPixels with 7 blue lights and 3 green lights.
They do it up there.
And so there's a web API you can call to get this.
Really?
It's very cool. And of course, and it's that much code on a Pico, and that sort of very immediate programming experience. You're not booting a Linux computer and then running Python on it. You have a machine that boots into Python in the way a Commodore 64 boots into BASIC. I think actually, if anything, it's doing a better job of certainly of reflecting my original views. Maybe maybe my original views were wrong, but I do perceive there's value in that very immediate programming experience.
Right. So yes, these were the questions for now.
Wonderful.
Thank you very much.
Well, thank you. I mean, thank you for letting us come and join you guys here. I mean, it's, as I say, my first Maker Faire in maybe 6 or 7 years, and definitely one to remember. Thank you.
Okay, thank you.